Welcome, dear dreamer, to the Dreamy Scientist. Tonight, we will wander together through the quietest of questions. One that stretches far beyond the edge of imagination. How big is the universe? Imagine lying beneath a dark sky, stars scattered like silver dust. Each one so distant, yet shining gently into your eyes. For thousands of years, humans have looked upward, wondering if the sky has an end, or if it goes on forever. Tonight, we will drift through that same wonder. We'll step softly through ancient stories, then into the discoveries of science. We'll ride on beams of light, measure across galaxies, and follow the whispers left behind from the birth of time itself. But don't worry, this is not a hurried journey. It is a calm unfolding. A gentle walk across cosmic distances. Slowly, like the rhythm of your own breath. So settle in. Let your mind grow quiet. The stars are waiting. And together, we will begin to explore how vast the universe truly is. When the very first humans looked up at the night sky, they did not see galaxies or light years, they saw mystery. They saw a ceiling of glittering fire, tiny points that seemed close enough to touch, yet unreachable. Imagine that moment, long before cities, before machines, before telescopes. A fire crackling on the ground. Shadows of trees swaying in the wind. And above, a sky so clear it felt like the earth had no roof at all. Those early eyes, wide with wonder, may have felt something you and I still feel. A hush. A quiet awe. The sense that what stretched above them was far larger than themselves. Perhaps larger than anything they could ever know. And so began humanity's first relationship with the universe. Not through science. Not through measurement. But through imagination. For countless generations, the night sky was a canvas for stories. Every culture painted its own. Some saw animals, like great hunters or winged creatures carved out of starlight. Others imagined gods sitting in thrones of flame. The stars became guides, protectors, omens. They gave comfort in darkness. They warned of seasons. They marked the passing of time. But deep beneath those myths was a common, unspoken question: how far does it go? Does the sky end, like a dome overhead? Or does it stretch forever? For people living thousands of years ago, these questions were almost too big to hold. Yet, even then, curiosity was awake. Picture a child from an ancient tribe, lying on the cool earth, tracing constellations with their finger. The stars seem close like lanterns hung just above the treetops. The moon, glowing and round, looks as if it might be reached by climbing a high mountain. And yet, the stars never move closer. They never fall. They remain silent, distant, unyielding. In that silence, the child dreams, if I could fly upward, how long would it take to reach the nearest star? A day? A year? A lifetime? Questions without answers. But these very questions are the seeds of science. The first great civilizations tried to answer them, not with numbers, but with stories. The Babylonians mapped the heavens with careful clay tablets, marking the paths of planets. The Egyptians aligned their pyramids with the stars, believing the afterlife itself was written across the night. In Greece, philosophers began to guess: was the universe endless, or was it finite? Some imagined a crystal sphere surrounding the earth, dotted with stars. Others dared to whisper, perhaps there is no edge at all. For those who believed in an edge, the sky was like a sheltering dome. Imagine standing beneath a painted ceiling, stars stuck onto its surface. Beyond that ceiling, perhaps there was fire. Or gods. Or nothing at all. For those who believed in infinity, the thought was more dizzying. A sky without end. A universe that never stops. Even today, that thought can make the mind spin. Think of how different the world was then. No glowing city lights. No airplanes. No satellites. The night was pure, black, unbroken. Millions of stars visible at once, each one sharp, each one luminous. The Milky Way, a pale river of light, stretched across the heavens. To early humans, it looked like spilled milk, or the breath of the gods, or a pathway for spirits. They had no way to know that this soft band of light was made of billions of stars, each one a sun, like our own. Standing beneath that sky, they must have felt both small and infinite. Small, because the heavens seemed unreachable. Infinite, because their imagination could travel where their bodies could not. That is the gift of the night sky, it awakens wonder. As you listen now, picture yourself there. No phone, no clock, no noise but the wind in the grass. Above you, the stars shimmer. They do not rush. They do not fade. They simply are. And in their stillness, they ask you to wonder. How high? How wide? How far? These questions are not new. They are ancient. They belong to every generation that has ever lived. From the first cave painters who drew constellations on stone, to the sailors steering ships by the North Star, to you lying here tonight with your headphones, drifting into sleep. The universe has always been both comfort and challenge. Comfort, because it is constant, always above us, always shining. Challenge, because it refuses to give its secrets easily. Early humans reached for answers the only way they could, with stories. The stars became hunters chasing prey. Lovers separated across the heavens. Heroes frozen in light. Each myth, in its own way, was an attempt to explain scale. How far, how big, how endless. And so, the first gaze at the night sky was more than just looking upward. It was the birth of a relationship. A relationship between humanity and the infinite. A relationship filled with questions. And in those questions, something beautiful began, the first steps toward science. But in those ancient nights, science had not yet taken form. There was only wonder. And perhaps, that is where all discovery truly begins. Not with tools. Not with data. But with a single quiet gaze into the stars. And as we rest here, under the same stars that once spoke to our ancestors, we feel what they felt. A shiver of awe. A whisper of infinity. The gentle thought, the universe is bigger than I can know. Soon, we will step into how humans tried to measure that bigness. The myths will slowly give way to mathematics, and to lenses of glass that stretched our sight. But tonight, before all of that, let us pause in this moment. Let us lie still, as they did. Let us simply gaze, and wonder. Long before rulers, telescopes, or equations, people still tried to measure the sky. They did not have numbers big enough, nor instruments delicate enough, but they had their senses. Their eyes. Their imagination. And above all, their patience. Imagine a group of early people sitting around a fire, embers glowing like tiny red stars. One of them points upward. The moon is full tonight, bright and heavy. How far is it, they might ask. Could a bird reach it? Could an arrow? Another might laugh softly, throwing a pebble upward, as if to test. Of course, the pebble falls back down. But the question remains, lingering in the smoke-filled air, how far does the sky go? With no tools, the universe had to be measured in comparisons. A child's outstretched hand could block the moon. A finger could cover a star. By this simple trick, the sky became something you could play with, shrink, and hold. And yet, the truth that those stars were unimaginably far away remained hidden. The earliest guesses were often poetic. Some believed the sky was close, a kind of ceiling. If the stars were lanterns, perhaps they hung only a few miles above. In some traditions, the heavens were described as layered, stacked one above the other, like the floors of a great house. Each layer home to different gods or spirits. To climb them, you would simply need to ascend far enough. Other imaginations stretched further. Perhaps the sky was like an endless sea, and the stars were ships floating upon it. Or perhaps the night sky was a great dome, with holes poked through it, and the light of eternity shining from behind. Each story was not just a myth, but a measurement. A way of saying, this is how big I think it might be. Practical minds, too, sought answers. Farmers needed to know when to plant, when to harvest. And so, they turned to the heavens. By watching the sun rise and set, they marked the length of days. By noticing which constellations appeared with the seasons, they marked the passage of the year. Though they could not measure distance, they could measure time. And in doing so, they began to feel the rhythm of the universe. The Babylonians charted the heavens with astonishing care. They etched star positions on clay, trying to predict their paths. They did not know how far the stars were, but they knew when certain ones would appear. The Mayans, too, tracked the skies, creating calendars so precise they astonish us even now. Again, not distance, but pattern. Not size, but cycle. Imagine lying in a field, staring at the moon. You notice that sometimes it is a thin crescent, sometimes half, sometimes full. If you wait long enough, you realize it repeats again and again, every month. You cannot measure how far it is, but you can measure its dance. And what of the stars? Some are steady, fixed in place. But others wandering stars, what we now call planets, move slowly, night after night. To the patient watcher, this was a clue, not everything in the sky was the same. Some things shifted. Some things stayed. The sky was not a painted ceiling, but something alive. Still, the question of size haunted the curious. In ancient Greece, philosophers debated. Some believed the stars were close, perhaps just beyond the moon. Others thought they were farther than the sun itself. One, named Anaximander, dared to suggest that the stars were like great wheels of fire, hidden behind invisible circles, and that we saw only glimpses of their light through small holes. His idea was strange, yet bold. It hinted at vastness, at machinery beyond sight. Centuries later, Aristotle would describe a universe of crystalline spheres. To him, the heavens were orderly, layered, finite. Each planet, each star, locked into its perfect orbit. Beyond the final sphere lay the unmoving, the eternal. A picture both comforting and limiting. For if there was a final sphere, then the universe had a boundary. It could be contained. But not everyone agreed. Some dared to whisper about infinity. The philosopher Archytas asked a question so simple, yet so unsettling, that it still stirs thought today. If the universe has an edge, then what lies beyond that edge? And if there is space beyond, then the universe is not truly bounded, is it? In this gentle riddle, the human mind brushed against infinity for the first time. But of course, whispers and riddles were not enough. People wanted to know more. Without tools, they began to invent little tricks. They noticed that when they walked across a field, objects in the distance seemed to shift against the background. This simple effect, called parallax, became a thought experiment. If the stars shifted when you moved, they must be near. But when they looked, the stars did not shift. Not even slightly. To the naked eye, they seemed perfectly fixed. And so, the conclusion was made, the stars must be unimaginably far away. Unimaginably far. Even without rulers or telescopes, people began to sense the truth that the universe was not small, not close, not easily measured. It was vast. So vast that even the cleverest tricks failed to capture it. And yet, this failure was also a kind of success. Because in realizing the stars could not be measured so easily, humans realized something else: they were tiny. Their world, though wide and full of life, was just a small stage beneath a sky of staggering depth. Picture yourself now, in that ancient time. You have no telescope, no science book. Only your eyes, your breath, and the endless sky. You stretch your arm upward. A star rests at the tip of your finger. You close one eye, then the other. The star does not move. It does not shift. It is so far that even your trick fails. And in that small failure, you feel something vast open inside you. The universe, you realize, is bigger than your reach. Bigger than your sight. Bigger than your guessing. And yet, you cannot stop asking. How big? That question, whispered beside fires, carved into clay tablets, hidden in myths, was the beginning of a long journey. A journey from imagination to measurement. From stories to science. From wonder, to discovery. So, before tools, before numbers, humans measured the universe in the only way they could, through stories, cycles, comparisons, and questions. They could not weigh the stars, but they could dream of their distance. They could not mark the edge of the sky, but they could wonder if it even had an edge at all. And perhaps, in some quiet way, that is the most important measurement of all. Not the number, but the wonder. The willingness to look up and say, it is bigger than me. And maybe bigger than I can ever know. Soon, though, humanity would begin to reach further. Glass would be shaped into lenses. Eyes would see farther than ever before. And slowly, the myths would begin to dissolve into measurements. The stars would stop being lanterns, and start becoming suns. But before that, let us rest in this twilight moment of history, when the universe was measured not with instruments, but with awe. A time when a child's hand could cover the moon, and yet the imagination could stretch across infinity. For thousands of years, people stared upward with only their eyes. Wonder was enough, for a while. But eventually, curiosity asked for more. Wonder whispered, what if we could see closer? What if the heavens were not just for stories, but for study? And so began the slow, delicate birth of astronomy, the art of giving structure to the sky. Imagine an ancient desert. The night is vast, the horizon low. A small group of people stand together, marking stones in the sand. They are watching the sun rise, noting the place where it emerges. Day after day, they return, carving small grooves into rock. Over weeks, then months, they notice a pattern. The sun does not rise in the same place each day. It shifts, ever so slightly, sliding north, then south, then back again. A cycle. A rhythm. The first calendar, written not on paper, but in the sky. This was astronomy in its infancy, not telescopes, not formulas, but patterns. The heavens became a great clock, and by watching closely, humans learned to read it. The Babylonians built careful records of star positions, scratched into clay tablets. They knew which stars heralded the flood of rivers, which ones announced the turning of seasons. The Egyptians aligned their great pyramids with the stars, their very tombs acting as giant markers of celestial order. In faraway lands, the Maya tracked Venus with precision, timing its appearances and disappearances, weaving them into ritual and prophecy. These were not idle observations. They were survival. Crops depended on the timing of rains. Journeys across deserts or oceans depended on the steady light of stars. To know the sky was to know life itself. And so, astronomy was born not just out of curiosity, but out of need. But even as patterns were recorded, a deeper longing stirred. Watching the heavens gave answers, yes, but also raised new questions. Why did the planets wander differently from the fixed stars? Why did the moon sometimes cover the sun? Was the earth truly the center of all this motion? Or was there something greater, some hidden machinery behind the stars? To find answers, humanity built tools. At first, they were simple. Sundials, casting shadows to mark the hour. Stone circles, like Stonehenge, where each rock was placed with intention, aligned to solstices. Later came the astrolabe, a brass disc carved with delicate markings, allowing sailors to measure the height of stars above the horizon. With such tools, humans could now not only watch the sky, they could calculate. Imagine standing on the deck of an ancient ship, waves rocking beneath you, a brass astrolabe in your hand. You lift it toward the North Star. The sea is endless, the sky immense, but this tiny instrument tells you where you are. Suddenly, the universe feels both vast and navigable. A paradox, held in the palm of your hand. Still, the stars themselves remain stubbornly small, points of light no brighter under any tool. The naked eye saw no more than the ancients had seen. For centuries, astronomy was a dance of patience, charts, cycles, predictions. And then, one day, a simple invention changed everything. Glass. The idea was almost laughable in its simplicity. Take two curved lenses, place them together, and suddenly, distant things appear closer. The telescope was not born from a grand observatory, but from tinkering hands in workshops. Yet when it was lifted toward the sky, it cracked open the heavens. Galileo Galilei was among the first to point this new instrument upward. What he saw must have been breathtaking. The moon, once smooth and perfect, was revealed as rugged, scarred with mountains and craters. The planet Jupiter, just a bright star to the naked eye, was surrounded by tiny moons, worlds in orbit of their own. And Saturn, that distant speck, wore a faint ring, delicate as spun glass. Each discovery was more than detail. It was a revolution. The sky was not fixed, not perfect, not made of crystal spheres. It was dynamic, alive, filled with objects as real and physical as the earth beneath our feet. Imagine Galileo, late at night, adjusting his telescope in silence. The streets outside are quiet, the air cool. He peers into the eyepiece, his breath catching as he sees something no human has ever seen before: moons circling another planet. In that instant, the universe grows larger. Not just the Earth, not just the Sun, but other worlds, too. Worlds that might be endless. The birth of astronomy was not gentle for everyone. These discoveries clashed with old beliefs. For centuries, many had trusted that the Earth sat at the center of creation, steady and unmoving. To suggest otherwise was bold, even dangerous. Yet the evidence was there, etched in starlight, undeniable through the glass lens. The universe was not what we thought. It was bigger, wilder, more complex. From these early nights of observation, astronomy grew quickly. Telescopes became larger, sharper. Records more detailed. New planets were discovered, faint comets tracked, even the motions of stars measured with precision. Slowly, humanity began to peel back the layers of the sky, like opening a book one page at a time. But in these first steps, the sundial, the astrolabe, the telescope, there was something more than invention. There was wonder. Imagine the first time a child looked through a telescope, their eye pressed to the cool glass, and saw the moon's craters. That gasp of surprise, that thrill of closeness. The universe, once distant, suddenly intimate. This intimacy changed us. It told us the sky was not untouchable. It could be studied, known, measured. It was not the unreachable ceiling of myth, but a place. A vast place, yes, but still a place, a landscape we could explore, step by careful step. And so, astronomy was born. Not as a dry science, but as a bridge between wonder and understanding. A way of taking the silent mystery of the stars and giving them form. A way of turning awe into knowledge. The birth of astronomy was not the end of questions. In truth, it was only the beginning. Each new discovery only deepened the mystery. If the moon had mountains, what else might be hiding among the stars? If Jupiter had moons, how many more worlds circled in darkness? If the Earth was not the center, then what was? The universe, instead of shrinking under the weight of knowledge, expanded. Each new tool opened more distance, more depth. Close your eyes for a moment and imagine being there at the turning of ages, when the sky stopped being myth and started becoming map. Imagine the thrill of that first telescope. The hush of realization. The sense that the universe was not fixed, but alive. Astronomy was not just born in those nights of discovery, it was born in us. In every one of us who has ever looked up, asked, measured, reached. For astronomy is not only the science of stars. It is the story of our longing to know, how big is the universe? There is a quiet magic in light. We see it every day, yet rarely think about what it is doing. It spills through windows at dawn, shimmers across water at noon, and fades into golden embers at dusk. To our eyes, it feels instant. A flick of a candle, and the room is lit. A spark in the night, and the darkness retreats. It seems so fast, so immediate, that for most of history, people assumed light moved with infinite speed. Instant, everywhere, timeless. But the universe, it has its secrets. And one of its deepest secrets is that light has a limit. A speed. A rhythm. And it is that rhythm, that cosmic heartbeat, that allows us to measure the size of the universe. Imagine for a moment, you are standing in a meadow at night. The stars are above, calm and steady. A shooting star streaks across the dark, leaving a glowing trail. To your eyes, it feels immediate. The light touches you without delay. But if you could slow the universe down, slow it to the pace of silence itself, you would see something different. Light is moving, traveling, racing toward you across empty space. Not instant, but fast. So fast that it takes only 8 minutes for the light of the sun to reach your face. So fast that in a single second, it can circle the earth 7 times. Yet not infinite. Always bounded by its great speed, 299,792 kilometers per second. The fastest thing known. This number may feel dry, but think of it like this: light is the only messenger quick enough to cross the universe. Without it, the cosmos would be silent. With it, we see into the past, billions of years deep. Because every time you look at the stars, you are not seeing them as they are now. You are seeing them as they were, long ago, when their light first began its journey. But how did we learn this truth? How did humanity, staring at the sky, discover that light was not instant, but finite? The story begins not with stars, but with moons. In the 1600s, a Danish astronomer named Ole Rømer was watching Jupiter. Through his telescope, he noticed its tiny moons orbiting, slipping into shadow and reappearing again. But something strange was happening. The timing of these eclipses changed, depending on whether the Earth was moving closer to or farther from Jupiter. At first, it seemed like a mistake. But then, Rømer realized, it was not the moons that were late. It was the light. The light itself was taking time to travel the extra distance across space. This was the first whisper of light speed, a cosmic clue hidden in the dance of moons. Later, experiments on Earth refined the measurement. Rotating mirrors, beams bouncing across distances, careful timing. Each one narrowed down the number, until we knew, light has a speed. Fast beyond imagination, yet not infinite. A limit written into the universe itself. Pause for a moment, and let that truth sink in. Every sunrise you see is 8 minutes old. Every moonlit night is 1 second delayed. The nearest star you glimpse, Proxima Centauri, shines with light that began its journey 4 years ago. And when we gaze at galaxies, spiraling millions of light years away, we are looking into deep time. Seeing history, not the present. The universe is not just wide in distance. It is wide in time. Light stretches across it like a thread, connecting us to the past. Think of light as both messenger and ruler. It tells us how far things are, by how long it takes to reach us. It defines the very word we use for distance in space, the light year. Not a measure of time, but of length. The distance light can travel in 1 year nearly 10 trillion kilometers. Trillion. Numbers that swell beyond human scale. To bring it closer, imagine this: if the Earth were the size of a single marble, then 1 light-year would stretch farther than a continent. And the nearest galaxy beyond our own, Andromeda, would be 2.5 million marbles away. That is what light teaches us. Vastness beyond imagining, made tangible through its speed. But light is not only ruler. It is limit. It sets the boundary of what we can see. Because the universe may be larger than our minds can dream, yet we are confined to what light has had time to bring us. This is why we speak of the observable universe, not because it is the whole, but because it is the part whose light has reached us since the beginning of time. Beyond that, hidden in silence, lies whatever may exist, unseen, untouched. So the speed of light is not just a number. It is the edge of our vision. A curtain drawn by the cosmos itself. Now imagine drifting in space. Alone, weightless. A star shines in the distance. You know its light has been traveling for hundreds of years to reach your eyes. You know, too, that when you move toward it, the light shortens, quickens. Move away, and it stretches, slows. The speed is constant, always the same, yet your motion shifts the song it sings. This strange truth, later woven into Einstein's theories, is the fabric of reality itself. Even here, in this quiet moment, you are bound by it. No matter how fast you run, no matter how swift your dreams, you can never outrun light. It is the speed limit of the universe. The final boundary. Everything, every star, every ship, every particle is held beneath it. And yet, rather than limiting us, this boundary gave us a gift. It gave us a way to measure the immeasurable. For by knowing how fast light travels, we could stretch our minds across galaxies. We could measure not just miles, but millions of light years. Not just days, but billions of years of history. The speed of light turned the night sky into a time machine. Look up, and you are gazing not at now, but at then, every star a storybook, every galaxy a page from long ago. So the next time you see the morning sun, pause for a moment. Think of its light, leaving the solar surface 8 minutes before it reaches your skin. When you look at the North Star, remember that its glow left over 600 years ago, long before you were born, long before your ancestors even dreamed of telescopes. Light carries history. Light carries scale. And light, in its constant, unfailing speed, carries the key to knowing just how big the universe is. The ancients measured with stories. The first astronomers measured with patterns and tools. But with the discovery of light's speed, humanity gained a ruler vast enough to span the stars. And so, the birth of astronomy met its perfect partner. Light, the fastest traveler, the endless messenger. Quiet, steady, always racing, always limited, yet always enough to tell us this one truth: the universe is vast. Far beyond our reach. And yet, through light, not beyond our knowing. Verso slightly against the backdrop of the farther ones. This tiny wobble, barely perceptible, became the first true ruler of the cosmos. From it, astronomers could calculate distances to nearby stars. For the first time, they had numbers, not guesses, not myths. Numbers carved from starlight itself. Yet the farther a star lies, the smaller its parallax becomes. Soon, the shifts grew too faint to measure. So humanity needed another beacon, another way. And the stars, as if eager to be known, offered their brightness. You see, not all stars shine alike. Some burn hot and fierce, blazing like white diamonds. Others glow cooler, softer, in shades of amber and red. Their brightness in the sky depends on two things: how much light they give off, and how far away they are. If we can know the true brightness of a star, then by comparing it to how bright it looks from Earth, we can find its distance. It is like knowing the wattage of a bulb, then seeing how dim it appears across the room. But how could we know a star's true brightness? This question lingered, a puzzle stretching across centuries. And then, in the early 1900s, a quiet breakthrough arrived. Her name was Henrietta Leavitt. Working at Harvard College Observatory, she studied a class of stars called Cepheid stars that pulsed, growing brighter and dimmer in a steady rhythm. She noticed something remarkable: the longer the cycle of their pulse, the brighter the star truly was. It was a cosmic heartbeat. And the rhythm revealed its power. With this discovery, stars became lighthouses in a new sense. By measuring a Cepheid's pulse, astronomers could know its true brightness. And by comparing that to its appearance in the night sky, they could calculate its distance even across galaxies. Henrietta Leavitt gave humanity a ruler that stretched beyond imagination. Her quiet work, often overlooked in her time, became the foundation for measuring the universe. Each pulsing star, like a beacon on a dark shore, pointed the way across cosmic waters. From parallax to pulsating stars, the universe began to unfold. Stars were no longer just points of beauty, they were markers, mileposts, signposts in an endless night. Their light became numbers. Their shimmer became scale. And yet, even as we measure them, the poetry remains. Imagine lying beneath the stars, hearing the story they whisper: I am not only a light in your sky. I am a distance, a depth, a page from long ago. My glow has crossed the emptiness to find you. In my shine, you see not only me, but the size of the universe itself. But there is more still. Some stars end their lives in violent explosions called supernovae. For a brief moment, they outshine entire galaxies. And among them, certain kinds always explode with the same true brightness, like identical cosmic candles. By measuring their glow, astronomers can gauge distances even farther, across hundreds of millions of light years. Think of that for a moment. A star dying, its light bursting outward, becoming so powerful that even from unimaginable distances, its brightness reaches us. And in that brilliance, it carries a message: here is how far I am. Here is the scale of the universe between us. Step by step, star by star, the universe revealed itself. Parallax for the nearest neighbors. Pulsating Cepheids for the distant galaxies. Supernovae for the farthest reaches we can glimpse. Like rungs on a cosmic ladder, each beacon led us farther outward. And what did we discover? That the universe is not small, not contained, but sprawling, immense, layered with depth upon depth. A Milky Way filled with billions of stars. A cosmos filled with billions of galaxies. Each star a light, each light a ruler, each ruler stretching us farther into infinity. Now pause with me. Look up, if you can, at the stars above you tonight. Know that they are not only beautiful, they are measurements. Each one shining across impossible gulfs, carrying information in its glow. To the human heart, they are poetry. To the human mind, they are rulers of distance. To both, they are wonder. The stars are beacons. Not only of navigation, not only of survival, but of discovery. They lit the way for sailors across the oceans, and now they light the way for us across the universe. Their light is the bridge. Their brightness the map. And as long as they shine, we will follow them step by step, farther and farther toward the edge of what we can know. Imagine for a moment that the universe is a grand painting. A canvas stretched across all directions, filled with stars and galaxies like colors brushed across the sky. For centuries, people thought that canvas was fixed, eternal, unchanging. The stars might move in small ways, but the whole backdrop was still, solid, permanent. And then came a discovery so quiet, yet so immense, that it shifted our understanding forever. Edwin Hubble, the astronomer whose name you've already met, had revealed that the Andromeda Nebula was not a cloud at all, but a galaxy of its own. That revelation alone multiplied the universe many times over. But Hubble wasn't finished. His telescope, perched high on Mount Wilson in California, was about to uncover something even stranger. Something that would change how we think of the universe itself. Hubble continued studying galaxies, carefully measuring their light. He was looking for patterns, distances, rhythms in the stars. And as he examined the light from galaxies far beyond our Milky Way, he noticed a curious shift. The light was stretched, pulled toward the red end of the spectrum. Astronomers called it redshift. To understand redshift, imagine the sound of a train whistle. As the train rushes past, the pitch of the whistle changes. It starts high as it approaches, then drops lower as it moves away. This is the Doppler effect, waves stretched or compressed depending on motion. Light behaves the same way. When a star or galaxy moves toward us, its light shifts slightly bluer, waves compressed. When it moves away, its light stretches redder. By measuring this shift, astronomers can tell if an object is approaching or receding. And what Hubble found was astonishing: almost every galaxy he measured was moving away. Their light was redshifted, stretched by motion. Not just some galaxies, but nearly all. And what's more, the farther away a galaxy was, the faster it receded. Pause with that thought. Every direction Hubble looked, galaxies were fleeing. The universe was not static. It was moving. Expanding. Like a balloon being slowly inflated, every point on its surface drifting away from every other point. This was no small correction. This was a revolution. For thousands of years, the universe had been imagined as fixed, eternal, unchanging. Now, suddenly, it was revealed to be alive with motion. The galaxies themselves weren't simply wandering through space, they were being carried by the expansion of space itself. Try to imagine it. Picture a loaf of raisin bread rising in the oven. Each raisin is like a galaxy. As the dough expands, every raisin moves farther from every other raisin. None is the center. None is special. All drift apart because the space between them stretches. That is our universe. Not galaxies racing like cars on a highway, but galaxies carried apart by the stretching of the fabric of space. The idea was breathtaking. If the universe was expanding now, then long ago it must have been smaller. Trace the expansion backward, and the galaxies draw closer together. Closer, until they merge into a single, dense beginning. From that seed, the universe burst outward, growing ever since. This was the seed of what we now call the Big Bang. Imagine living in Hubble's time, in the 1920s. The Milky Way had just been humbled, revealed to be one galaxy among countless others. And now, the entire universe was revealed to be stretching, expanding, growing larger every second. The cosmos was not a static palace. It was a story unfolding. A story with a beginning. For many, it was disorienting. For others, electrifying. Scientists who had once pictured the cosmos as eternal now had to face a universe with motion, history, perhaps even an origin. Sit with that thought a moment. The light you see from a distant galaxy is stretched because space itself has stretched during its journey. Each photon is like a note of music pulled longer, slower, softer, until it arrives at your eyes millions or billions of years later. In that stretch of light is written the history of the cosmos. Hubble's law, as it came to be known, gave us a new ruler for measuring the universe: the farther away a galaxy is, the faster it recedes. That relationship became the heartbeat of cosmology. From it, scientists began to estimate the age of the universe, its growth, its possible future. But tonight, we don't need to calculate. Tonight, it is enough to let the wonder sink in. To breathe slowly, and picture galaxies drifting apart like lanterns on a dark sea. Each one glowing softly, carried not by their own will, but by the invisible tide of space itself. Look up at the night sky, and know that everything you see is moving. Slowly, silently, with a rhythm that stretches across billions of years. The stars may seem fixed to the naked eye, but the galaxies, they are sailing outward, away from us, and away from each other. The universe itself is growing wider. This discovery reshaped more than science. It reshaped perspective. No longer could we say the cosmos was still. No longer could we imagine eternity as a frozen dome. Instead, we learned we live inside a living expansion. A universe with a past. A universe with a future. And what does that mean for us? Perhaps that change is not only part of life on Earth, but part of the cosmos itself. Stars are born and die. Galaxies collide and merge. Space stretches and grows. Everything moves. Everything transforms. So as you rest, imagine the quiet rhythm of this expansion. Imagine galaxies as tiny boats, drifting slowly, endlessly, carried apart by a current so vast it cannot be felt. Imagine space itself breathing, inhaling, exhaling, stretching across eons. That is the legacy of Hubble's discovery. The universe is not just vast. It is growing vaster with every moment. And in the silence of that knowledge, there is a strange comfort. We are part of a story still unfolding. Close your eyes for a moment, and think about distance. On Earth, we measure distance in steps, in miles, in hours of travel. A walk across a room takes seconds. A drive across a city takes minutes. A journey across a country might take days. We can hold these scales in our minds. We can imagine them. But space refuses to fit inside these simple measures. Astronomers had to invent new rulers. Distances so large, so alien to our experience, that even the words feel like whispers from another world. The most famous of these is the light year. A light year is not a time. It is a distance. It is how far light travels in 1 year. And light, the fastest thing in the universe, races at 186,000 miles every second. Each heartbeat you feel, light has already circled the Earth 7 times. And yet, when you let it run for a full year, it has crossed nearly 6 trillion miles. That vast span is 1 light year. When astronomers say a star is 10 light years away, they mean the light you see tonight began its journey 10 years ago. The star you gaze upon is not what it is now, but what it was then. To look into space is to look back in time. Even the nearest star beyond our Sun, Proxima Centauri, is 4.2 light years away. Imagine driving to it at highway speed 60 miles per hour, never stopping, never sleeping. You would arrive after more than 48 million years. The mind cannot quite grasp it. So instead, we let the numbers float softly, like clouds drifting. And that's just the nearest star. Our Milky Way galaxy is about 100,000 light years across. Picture that. A river of stars stretching so wide that even light, running tirelessly, takes 100,000 years to cross from one side to the other. Inside this spiral home are hundreds of billions of stars, each with worlds and mysteries of their own. And beyond the Milky Way, the scale deepens still. The Andromeda Galaxy, our closest large neighbor, is more than 2 million light years away. The light reaching your eyes tonight left Andromeda when early humans were first learning to shape stone tools. That light has crossed 2 million years of space, carrying the memory of another galaxy to us. Lift your gaze higher still, and you enter the realm of billions of light years. Galaxies scattered like dust, each one separated by gulfs of such magnitude that words begin to falter. Pause here. Let yourself feel it. When you stand beneath the night sky, you are not surrounded by close companions. You are perched on a small world, looking out across unimaginable oceans. Stars twinkle, yes, but they are not lanterns above a village square. They are islands across gulfs so large that even the fastest traveler we know light struggles to reach us in human terms of time. To make it gentler, let's shrink the scale. Imagine the Earth is the size of a single grain of sand. On that scale, the Sun would be a small marble just a few feet away. The nearest star? Another marble, not across the room, not across the street, but hundreds of miles away. Now picture the Milky Way. On this sand and marble scale, it would stretch across continents. And beyond it lie billions of other galaxies, scattered like endless beaches. Try to walk them all, and you would never finish. And yet, this is not empty space. Between these galaxies, the universe continues to stretch. Expansion itself adds to the distance. It is as though the road is lengthening while you walk it, always just a little farther than it was before. Astronomers can map this immensity, but for us, it is enough to feel the awe. To know that our ordinary human rulers' miles, hours, days are too small for such a cosmos. And yet, through imagination, we can gently stretch our minds to touch it. What is the size of the observable universe, then? Roughly 93 billion light-years across. A sphere of visibility, centered on Earth, not because we are special, but because light has only had so long to travel since the universe began. Beyond that sphere lies more, perhaps endlessly more, hidden behind a horizon we cannot yet see. 93 billion light-years. A number so vast that even whispering it feels like standing at the edge of an ocean with no shore. But here is a comforting truth. Even if we cannot hold the scale in our hands, we can feel its wonder in our hearts. The universe is not asking us to count every mile. It is asking us to look upward, and to know that the story is grand. That we are small, but not insignificant. That our questions reach farther than our footsteps, and that is its own kind of journey. So tonight, let distance be not a burden, but a lullaby. Let the light years drift past you like waves. Let galaxies sail outward like fireflies in the dark. And let yourself rest in the simple, soothing thought, the universe is immeasurable, and yet, somehow, we are here to measure it. Close your eyes, breathe slowly, and imagine standing in the center of a vast, endless meadow. All around you, stretching in every direction, is space. You can look outward as far as your eyes will allow, but eventually, the horizon fades. Not because the meadow ends, but because your sight does. This is the same with the universe. When astronomers speak of the observable universe, they are not claiming it is the whole thing. They are speaking only of the part we can see, the cosmic horizon drawn by light itself. The story begins with a simple truth: light has a speed, and time has a beginning. Our universe is about 13.8 billion years old. That means the farthest light that could possibly have reached us began its journey 13.8 billion years ago. If the universe were frozen and still, our observable sphere would be 13.8 billion light-years in radius. But the universe is not still. It is expanding, like a balloon slowly being inflated. Galaxies are being carried away, further and further, not because they are moving through space, but because space itself is stretching. So the actual distance to the edge of what we can see is far larger, about 46 billion light-years in every direction. That makes the full observable universe nearly 93 billion light-years across. Pause a moment with that number, 93 billion. It doesn't just sit on the tongue, it echoes. It is not meant to be fully grasped. It is meant to remind us that there are scales beyond comfort, beyond imagination. And yet, it is not infinite. That's the curious, calming twist. The observable universe is like a glowing bubble, with us at the center, not because we are special, but because each point in space has its own bubble. Every galaxy, every star, every drifting atom has its own sphere of visibility. From where we stand, the bubble is ours. From another galaxy, far away, their bubble overlaps and stretches differently. So when you imagine this observable cosmos, picture not one single bubble, but countless overlapping ones, like soap bubbles floating together, each one limited by how far light has traveled. Inside our bubble lies everything we can study. Stars blazing and dying. Galaxies colliding like swirls of paint. Clouds of gas birthing new suns. Black holes hidden in shadows. Even the faint afterglow of the Big Bang itself stretched into radio waves, a cosmic whisper. Outside it? Mystery. Darkness. Perhaps other galaxies, other stars, other wonders. But they are hidden, beyond reach. Not because they don't exist, but because their light has not yet arrived. Think of it like standing at the shore of an ocean on a misty night. You see the waves nearby, glimmering with moonlight. You sense the vast sea beyond. But the fog hides it. You cannot see past the mist, yet you know the ocean stretches farther than your vision. What makes the observable universe feel so extraordinary is that it is both enormous and fragile. We measure it with delicate instruments, with telescopes that gather whispers of light. We trace its shape through faint radiation that has traveled across nearly the whole of time. We trust equations, born from human thought, to tell us what lies beyond our reach. And as we map it, we find not chaos but structure. Galaxies are not scattered randomly, they form filaments, cosmic webs, and vast walls stretching across unimaginable expanses. Between them lie immense voids, dark regions nearly empty, where galaxies are few and far between. The universe, on the largest scale, is not a uniform fog, but a woven tapestry. Close your eyes and picture it, a three-dimensional lace, with glowing threads of galaxies and stars. Each point of light is a sun, each cluster a city of billions of suns, all connected in a pattern that looks almost alive. And we, on our little planet, are like a single grain of dust caught in that endless net. This is the observable universe, a window through which we can glimpse the grand pattern, even if not the whole design. And here is the wonder, this cosmic horizon is always changing. With each passing year, light from slightly more distant regions has had time to reach us. The observable universe grows, slowly, like a flower opening petal by petal. New galaxies drift into sight, while some, pushed by expansion, slip away beyond reach. It is a balance, an eternal dance between what is revealed and what is hidden. So the universe we see tonight is not fixed. It is a living portrait, shifting gently with time. But in the quiet of this bedtime thought, what matters most is not the exact number of light years. It is the feeling. The comfort of knowing that there is a limit, a boundary drawn not by walls or endings, but by light's patient journey. It tells us, this is what you may see, for now. Beyond it, wait. And perhaps that waiting is part of the beauty. To know there are always more mysteries, just beyond the horizon. To know that the story of the universe is never fully told, but always unfolding. So rest now, with this picture in mind. A glowing sphere. 93 billion light-years across, surrounding us like a delicate lantern in the dark. Inside it lies every star you will ever see. Every galaxy we can ever map. Every cosmic tale science can tell. Outside it, the unknown waits quietly, like the night beyond your window. And as you breathe, slowly, gently, you can imagine yourself floating at the very center of this cosmic lantern. A tiny being, wrapped in the vastness of everything visible, resting beneath the quiet hum of the stars. Imagine, if you will, the universe as a newborn. Not yet stars, not yet galaxies, not yet anything that we would recognize as beautiful or grand. Only heat, only light, only the first trembling breath of existence itself. Tonight, we return to that ancient moment. To the softest glow that still surrounds us, everywhere, even now. Astronomers call it the cosmic microwave background. But you may think of it as the universe's first lullaby, still humming, after almost 14 billion years. When the universe began, it was not dark. It was dazzling. So dense, so hot, that light itself could not travel freely. Imagine standing inside a blazing fog, so thick that every photon the tiny packet of light was instantly trapped, scattered, ricocheting endlessly, unable to escape. For hundreds of thousands of years after the Big Bang, this fog filled everything. The universe in that age was not a place of stars or planets. It was a glowing soup of energy and particles. Protons, electrons, photons all dancing together in an endless storm. If you had been there, you would not have seen anything at all, because light could not travel in a straight line. It would have been like trying to see across a bonfire. But time passed, and the fire cooled. The universe expanded, stretched, and grew calmer. And then, about 380,000 years after the beginning, a quiet transformation took place. The fog thinned. Electrons settled into atoms. For the first time, the universe became transparent. And in that instant, light was free. Photons slipped loose, no longer bound, no longer scattered. They began their journey outward. And they never stopped. Those very same photons, those messengers of first light, are still traveling. Still stretching across space. Still arriving here, where we can catch them. This is the cosmic microwave background, the oldest light we can see. A faint afterglow from the moment the universe cleared its throat and allowed light to sing. But here's the dreamy part. To our eyes, this glow is invisible. It is not bright. It is not like sunlight or starlight. It is faint, stretched into microwaves, a form of light too soft for human vision. It whispers all around us, passing through the air, through walls, through our own bodies. At every moment, you are bathed in this ancient glow, without even knowing it. Astronomers first stumbled upon it by accident. In 1964, two scientists, Arno Penzias and Robert Wilson, were testing a radio antenna. No matter what they did, no matter where they pointed it, they picked up a strange background hiss. At first, they thought it was static, or maybe interference, or even pigeons nesting inside the antenna. But after careful checks, the hiss remained. It was everywhere, constant and unyielding. That static was the echo of the Big Bang itself. The universe's first light, stretched and softened, singing quietly across the sky. Close your eyes, and imagine it. A glow older than stars, older than galaxies, older than time as we measure it. It comes not from any one direction, but from all directions at once. No matter where you look, it is there. A gentle background, the universe's memory of its own childhood. And what does this light tell us? It tells us that the universe has a beginning. It tells us that it was once hot and dense, filled with a fire now cooled. It tells us that the cosmos is not eternal in its present form, but a story with a first chapter. It also carries faint ripples, tiny variations in temperature, one part ever so slightly warmer than another. These ripples are like seeds. The first hints of structure. Where the light was a little denser, matter would gather. And from those ripples, over billions of years, galaxies would form. Stars would ignite. Planets would emerge. Life, eventually, would awaken. So, in a sense, everything you see tonight, the stars, the Milky Way, your own reflection, was written first in those ripples. The cosmic microwave background is not just a glow, it is the blueprint of the universe. Pause for a moment, and let that settle. Every breath you take, every atom in your body, every star shining in the night sky, all of it traces back to patterns frozen into that faint, ancient light. And yet, it is so quiet. To detect it, astronomers must build special instruments, tuned not to brightness, but to whispers. Satellites like COBE, WMAP, and Planck have mapped it with delicate precision, revealing a mottled sky, like the soft speckle of old parchment. Each spot, a clue. Each variation, a story. The image they produced is humbling. Not a perfect glow, but a gentle pattern of tiny differences. A cosmic fingerprint. A baby picture of the universe, captured when it was less than 500,000 years old. Think of that. We have, hanging in our records, the earliest portrait of everything. Not of Earth. Not of our galaxy. But of the universe itself. Its very first smile, frozen in light. The universe has grown since then. What was once a blazing soup has become galaxies and stars. What was once opaque has become transparent. And yet, the glow remains. Tonight, as you listen, you are wrapped in it. The afterglow of creation itself, falling gently across your skin, like the faintest, most ancient lullaby. And here is the quiet comfort: the cosmic microwave background tells us we are not in darkness, not really. Even in the emptiest stretch of space, there is still light. Faint, stretched, cooled to just a few degrees above absolute zero, but there. A reminder that the universe remembers. Perhaps, as you drift to sleep, you can imagine yourself not as a small being lost in an indifferent cosmos, but as a listener in a vast cathedral of time. And the background hum you cannot hear? It is the echo of the very first fire. It is the heartbeat of everything. So let it cradle you. The universe's first light, still glowing, still here. Carrying across almost 14 billion years, just to find you tonight. Imagine for a moment that you are holding a balloon in your hands. It is small, uninflated, quiet. Now slowly, gently, you breathe air into it. With each breath, the balloon grows larger. Not because the dots on its surface are moving, but because the surface itself is stretching. This is the closest way we can imagine the universe. Not a stage on which galaxies move about, but a fabric that itself is stretching, carrying galaxies apart as it grows. The galaxies are not racing through empty space like cars down a highway. Instead, the highway itself is lengthening beneath their wheels. The universe is not static. It is expanding. And this idea, though simple in words, is one of the most profound truths we have ever discovered. For thousands of years, humans assumed the cosmos was eternal and unchanging. The stars, it seemed, were fixed. The heavens, though moving in patterns, felt steady and permanent. Even Einstein, when first writing his equations of relativity, resisted the idea of an expanding universe. He added what he called a cosmological constant, a patch to make the math agree with a still, unmoving cosmos. But the universe itself refused to be so easily contained. In the 1920s, an astronomer named Edwin Hubble began to measure the light from distant galaxies. Using the great telescopes of Mount Wilson in California, he peered into the night and noticed something astonishing. The galaxy's light was shifted toward the red end of the spectrum. This redshift was not a trick of the eye. It was a sign that the galaxies were moving away from us. And not just some of them. Nearly all of them. The farther away a galaxy was, the faster it seemed to be receding. It was as if the entire universe was pulling apart, every starry island drifting away on a great invisible tide. Pause for a moment, and let that sink in. When we look at the night sky, we are not looking at stillness. We are looking at motion. Every galaxy is part of a great outward sweep. The Milky Way itself, our home, is not standing still. It too is carried along on this cosmic stretching. Imagine standing on a shore, watching ships sail away across a wide ocean. The farther they go, the smaller they seem, and the quicker they vanish into the horizon. That is what Hubble saw, except the horizon was not an ocean's curve, it was the curve of time itself. The expansion is not like an explosion throwing fragments into space. That is a common misunderstanding. No, there is no center, no edge, no empty background into which things are flung. Expansion is everywhere, all at once. Every part of space is stretching, carrying galaxies farther from each other, while each galaxy remains mostly bound together by its own gravity. Think again of the balloon. If you draw tiny dots across its surface and then inflate it, each dot seems to move away from every other dot. Yet none of the dots is the center of expansion. The whole fabric itself is stretching. That is our universe, except not on the surface of a balloon, but in all three dimensions of space, everywhere, without end. And here lies the dreamy wonder: if the universe is expanding today, then long ago it must have been smaller. If you rewind the film of cosmic history, galaxies draw closer, space tightens, and the universe contracts. Eventually, you reach a time when it was unimaginably compact and hot, the moment we call the Big Bang. So the expansion is not just a fact about the present. It is the thread that ties us to the very beginning. It is how we know the universe has a history, a birth, an evolution, a story unfolding across time. But what does expansion feel like? It is not something we notice in daily life. The distance between you and your chair does not grow larger. The space inside your room is not stretching. Why? Because gravity, and other forces, hold small things tightly bound. Expansion only shows itself on the largest scales between galaxies, across gulfs of millions of light years. It is a quiet tide, patient and relentless. Over billions of years, galaxies slip farther apart, stars grow more isolated, the night grows deeper. If you lived in a far future, so distant that billions of years had passed, the sky would look emptier. Galaxies that we see now would have vanished beyond the limits of sight, carried away on the stretching of space. And yet, expansion is not uniform. Some galaxies resist. The Andromeda Galaxy, for instance, our great neighbor, is not rushing away. Instead, it is slowly moving toward us, pulled by gravity stronger than the expansion between us. In about 4 billion years, the Milky Way and Andromeda will merge into one great island of stars. Even in a universe that expands, local dances continue. So expansion is not a single note, but a symphony, some parts swelling outward, others bound close together. A balance of gravity and stretch, of pull and release. Think of it another way. Imagine a river flowing endlessly downstream. On its surface, driftwood pieces float apart, carried by the current. But sometimes, near eddies or bends, two pieces come together, swirling in little dances even as the river continues to flow. That is our cosmic river. Galaxies may join, but the current of expansion carries the greater whole away. When astronomers mapped this expansion, they discovered something even more beautiful: it is accelerating. The fabric of the universe is not just stretching, it is stretching faster and faster. Some mysterious force, which we call dark energy, is at work, urging galaxies apart with growing speed. We will drift deeper into that mystery later. But for now, let this thought cradle you: the universe is not static. It breathes, it grows, it unfolds. Like a flower in slow, endless bloom. And in the gentle hush of night, when you gaze at the stars, remember this. You are not looking into stillness. You are looking into motion. Every pinprick of light is part of a grand, expanding story. A story written not in haste, but in the soft, patient rhythm of billions of years. So let the thought soothe you. The universe stretches around you, carrying galaxies in a dance without end. You, too, are part of this motion. A traveler on the fabric of space, carried gently on the tide of expansion, forever woven into the growing cosmos. Close your eyes for a moment and picture yourself standing on a quiet shore. The sea stretches out before you, calm and endless. Yet even the sea has a horizon, a line where the sky kisses the water, a limit beyond which you cannot see. You know the ocean continues past that line, but your eyes, your vision, cannot follow. The universe is like that. Vast beyond measure, yet with horizons that limit our sight. Astronomers call it the cosmic horizon. A boundary not made of walls or edges, but of light itself. Beyond it lies a realm we cannot see, and perhaps never will. Not because it isn't there, but because light from those distances has not had enough time to reach us. To understand this, imagine a lantern lit in the darkness. If you are close, you see its glow immediately. If you are far away, it takes longer for the light to arrive. Now think of the universe itself. The Big Bang happened around 13.8 billion years ago. That was the moment when light could first begin its journey across space. And ever since, beams of light have been traveling outward in all directions. Some of them, after billions of years, are only now reaching us. Those ancient beams form the limit of what we can see. Anything farther away is like a lantern whose light has not yet arrived. A silence beyond sight. This gives us our observable universe. A great sphere centered on us, about 46 billion light-years in radius. Not because the universe is only that size, but because that is as far as light has traveled to meet our eyes. The universe itself may stretch much farther, perhaps infinitely farther. But our vision, bound by the speed of light and the age of time, has a horizon. It is humbling to imagine, we stand inside this vast bubble of sight, a glowing sphere of everything we can observe. Beyond it, the unknown. A darkness not empty, but simply hidden. And yet, even this horizon is not still. Because the universe expands, galaxies that once were visible to us may someday slip beyond our reach. Their light will grow too faint, stretch too far, carried away on the tide of expansion. Someday, billions of years from now, the horizon will close in around future astronomers. They will see fewer galaxies, fewer clues of the great cosmic story. To them, the universe may appear small, lonely, a sky nearly empty. But we, here and now, live in a fortunate moment. Our cosmic horizon is filled with galaxies upon galaxies, billions of starry islands shining across the night. We can trace their light back to the beginning, reading the story written in their glow. Think of what it means. A horizon is not an end, but a veil. The ocean continues past the line you see. So too does the universe. We simply cannot yet follow. But the human mind, it longs to peer beyond, to dream past the curtain. We imagine what lies further: more galaxies, more light, perhaps endless worlds drifting in the dark. Astronomers sometimes compare this to being inside a forest. You see the trees around you, close and clear. Beyond them, shadows hide the deeper woods. You cannot see every tree in existence, yet you know the forest continues. That is our position in the universe. A forest of galaxies surrounds us, as far as sight allows. But past that, the deep woods stretch on. There is another kind of horizon too, the event horizon of the universe. This one is stranger. Because the expansion is accelerating, there are galaxies we can see today whose light will never again reach us in the future. They are already slipping beyond a horizon of no return, like ships sailing beyond a tide too strong to resist. It means that even as the universe grows, our future sky will shrink. We are watching some galaxies for the very last time. Their light, arriving now, is a farewell letter written billions of years ago. Once it fades, they will vanish beyond the cosmic horizon, unreachable forever. This horizon, both visible and invisible, is one of the most poetic truths of science. It reminds us of our limits. We cannot see everything. We cannot know everything. The cosmos holds secrets forever hidden beyond our reach. And yet, we glimpse enough to feel its immensity. It is like walking at night with a lantern. The small circle of light around you is all you can see. But the darkness stretching out into mystery tells you the world is vast. The limit of sight is not the limit of reality. Sometimes, when I think of the cosmic horizon, I imagine it as a great curtain of starlight. Beyond it, unseen galaxies drift silently, stars burn and fade, worlds turn in orbits. Life may bloom and vanish in complete invisibility to us, never known, never touched. And still, the universe will carry on, whether we watch or not. And here we are, within our fragile bubble of sight, peering outward like children pressing their faces to a window, longing to see more. Yet, this very limit gives the universe its wonder. If we could see everything at once, perhaps the mystery would fade. The horizon, the veil, keeps alive the sense of infinity. It whispers to us that there is always more. Always beyond. So the next time you gaze at the stars, remember, the sky above you is not just a ceiling of twinkling lights. It is the edge of an ocean of time. A horizon stretched 46 billion light-years in every direction, filled with light that has traveled almost since the dawn of creation. And beyond that horizon, more waits, unseen, perhaps forever unseen, but no less real. And in this thought, there is a gentle peace. We are not meant to grasp it all. We are meant to wonder. To sit beneath the stars, feel the hush of the night, and know that the universe is larger than our sight, larger than our minds, larger even than our dreams. The horizon is not the end. It is an invitation. To dream further. To imagine more. To rest in the mystery. Close your eyes, and imagine the night sky again. Stars scattered across the darkness. Galaxies like drifting islands. You might think of them floating still in space, like lanterns fixed in the air. But the truth is far more dreamlike. The universe is not simply filled with galaxies, it is stretching. Expanding. Like the surface of a balloon, slowly blowing larger and larger, carrying every star and galaxy farther apart. This idea alone feels strange. Space itself is growing. The distance between distant galaxies isn't caused by their motion through space, but by space itself creating more room. A quiet, steady stretching of the very fabric of reality. For a long time, scientists thought this stretching would slow down. After all, gravity pulls everything together. Galaxies attract one another, stars tug on their neighbors. The universe, they thought, would eventually stop expanding, perhaps even collapse back inward in a cosmic fall called the Big Crunch. But then came the surprise. A discovery so unsettling, so astonishing, that even today it feels mysterious. In the late 1990s, astronomers looked at distant exploding star supernovae. These bright explosions acted like cosmic lighthouses, markers that told scientists how far away galaxies were, and how fast they were moving. The results were clear: instead of slowing down, the universe's expansion was speeding up. Imagine throwing a ball into the air. You expect it to rise, slow, then fall back. But in this strange cosmic version, the ball rises faster and faster, as if some invisible hand were pulling it upward. That is what the universe is doing. Expansion is not decelerating, it is accelerating. And so, to explain this unseen push, scientists gave it a name: dark energy. What is dark energy? That is the quiet riddle. It is not light, not matter, not something we can touch or see. Yet it fills space, pressing outward, a hidden force woven into the fabric of the cosmos. We know it exists only by its effect: galaxies carried away faster and faster, the universe stretching in an endless rhythm. Some describe it as the energy of emptiness itself, the vacuum of space whispering expansion into being. Others imagine it as a property of the universe's geometry, a built-in feature of space. But no one knows exactly. It is as though the universe keeps its greatest secret close, allowing us only to see the results, not the cause. Let's pause here. Breathe slowly. Think of a balloon in your hands. As you blow into it, every point on the surface moves away from every other point. If you were a tiny creature living on that surface, you would see all of your world stretching outward, without ever finding a center. That is our universe. Everywhere is expanding away from everywhere else. And dark energy is the hidden breath filling that balloon. Astronomers estimate that nearly 70% of the entire universe is this dark energy. 70%. The stars, the galaxies, the atoms that make your body and mine, those make up only a small slice. Most of the cosmos is this unseen, mysterious energy. The numbers are staggering. Yet here, told softly in the dark, they sound more like poetry. The universe, it seems, is made mostly of something we cannot see, cannot touch, and do not fully understand. And still, it carries everything outward. Now imagine the future. If dark energy continues its steady work, galaxies will keep drifting farther apart. In billions of years, light from distant galaxies will stretch until it fades, disappearing beyond the cosmic horizon. The night sky will grow emptier, quieter. Civilizations in that far future may see only their own galaxy, unaware of the great cosmic ocean that once filled the sky. And if dark energy grows stronger, the universe may face an even stranger fate. Some theories suggest a scenario called the Big Rip. In this vision, dark energy's expansion becomes so fierce that it tears galaxies apart, then stars, then atoms themselves. Space stretching until nothing can hold together. Others suggest the expansion may balance, reaching a kind of gentle eternity, forever stretching but never tearing. And some wonder if dark energy could change, shift its nature, perhaps even reverse. If that happens, the universe might one day slow down after all, leading to collapse. The truth is, no one knows. Dark energy keeps its secret close, like a dream that fades when you wake. We see the signs, the cosmic footprints, but the source remains hidden. There is something humbling in this mystery. The universe, vast and ancient, is shaped mostly by something invisible. Something we cannot yet name with certainty. It reminds us that science, though powerful, is also a story always unfolding. Each answer opens a new question. Each discovery deepens the wonder. When I think of dark energy, I imagine it as a kind of gentle tide. Not rushing, not violent, but steady and quiet, carrying galaxies like little boats farther out to sea. The ocean of space expands beneath them, wave upon invisible wave. And we, tiny passengers on our small Earth, drift with it sailing through the silence. Pause here, and breathe. The stars above you are moving away, carried by this hidden force. The space between them is stretching, softly, endlessly. And though you cannot feel it, though the ground beneath you seems still, you too are part of this cosmic drift. Every breath you take is set against a backdrop of infinite expansion. And isn't it wondrous? To know that the very emptiness of space hums with energy. That nothingness itself can shape the destiny of everything. It is like listening to silence, and realizing the silence is singing. Dark energy may forever remain a mystery. Or perhaps, someday, a new discovery will reveal its nature, like a curtain pulled aside. But whether we understand it fully or not, its presence reminds us of one truth: the universe is stranger, more beautiful, and more mysterious than we can ever imagine. And that strangeness is a gift. For it keeps alive the wonder. It keeps us looking up. It keeps us dreaming. So tonight, as you drift toward sleep, remember, the universe is not still. It is stretching, expanding, carried outward by a hidden energy, gentle and unstoppable. Galaxies drift like leaves on a cosmic river, and we are among them. Floating, quietly, into the endless stretch. Close your eyes, breathe in slowly, and let the thought arrive. If the universe is expanding, if it is filled with galaxies upon galaxies, does it go on forever? Or does it have an edge, some boundary where everything stops? This is perhaps the most dreamlike question of all. Infinite or finite? Endless or contained? For thousands of years, humans have wrestled with this idea. And tonight, we will wander gently through it, step by step. Imagine yourself standing at the edge of an ocean. The water stretches to the horizon, shimmering under the moonlight. You cannot see the end, though you know the earth is round, and eventually the sea will curve back upon itself. The universe may be like this. It may appear endless, yet be curved, folded in ways our minds can only dimly picture. Some scientists believe the universe could be finite, but unbounded. A shape without edges, like the surface of a sphere. You can walk forever on the surface of a globe, never reaching an edge, yet the surface area is still finite. In this vision, space itself may be curved. You could travel in one direction long enough, and in some unimaginable future, find yourself back where you began. A cosmic loop, too vast for human travel, but not for human imagination. But others wonder, what if the universe truly is infinite? Stretching endlessly, with no edge, no boundary, no final wall. An infinity of stars, galaxies, clusters, repeating without end. If so, then everything you see above your head is just the tiniest window into an endless ocean of light. To picture infinity is not easy. Our minds are built for fields, mountains, rivers, horizons we can measure. Infinity is not a number, but an idea, an unending road that never curves back. When you try to grasp it, it slips through your thoughts, leaving only wonder behind. And yet, infinity feels strangely comforting. For if the universe is infinite, then there is always more. Always farther to go, always something beyond the horizon. Still, infinity raises deep riddles. If the universe is truly infinite, then every possible arrangement of matter could exist somewhere. Another Earth. Another you, sitting beneath another sky, listening to another story. Not because of fantasy, but because infinity allows all patterns, given enough room. That thought is both unsettling and beautiful. Let us turn back to science. When astronomers look deep into the cosmos, they search for signs of curvature, of bending light, of the universe's shape. The results so far suggest something extraordinary. The universe seems flat. Not curved like a ball, not curled like a saddle, but flat, at least as far as we can measure. What does this mean? It means the universe could be infinite. Or it could be finite, but so vast that its curvature is too gentle for us to detect. Imagine standing in a wide plain, so large you cannot see its curve. To your eyes, it seems flat, endless. But if you could soar high enough, you might notice it bending, curving back on itself. That may be our universe, flat for now, but curved on scales we cannot yet reach. And what of an edge? Could the universe have one, a final boundary? The idea is tempting. To think of space as a great sphere floating in nothingness, with an outer wall we might someday touch. But here, science gives us a gentle correction: the universe is not expanding into anything. Space itself is what expands. There is no outside, no edge. Asking what lies beyond the universe is like asking what is north of the North Pole. The question fades, dissolves. The universe is everything, and everything is inside it. Still, the thought of beyond lingers. Our minds reach for it, like hands reaching for a shape in the dark. Perhaps the boundary is not physical, but conceptual. Perhaps beyond is simply where our imagination goes when we press against the limits of what can be known. Now, breathe slowly. Imagine the night sky again. Millions of stars, scattered across the dome of darkness. You see only a fraction. The observable universe, what light has had time to reach us, is vast beyond words, nearly 93 billion light-years across. But beyond that, we cannot see. We cannot know. And yet we suspect there is more. Much more. So here we sit, dreamers on a small world, asking the oldest of questions. Is the universe finite, or infinite? The answer may forever escape us. And perhaps that is the point. Some mysteries are not meant to be solved quickly. Some are meant to remain open, so that wonder never dies. There is poetry in both possibilities. If the universe is finite, it is like a great story, written with a beginning, a middle, and perhaps one day an end. Every galaxy, every star, every atom part of a complete whole. To live within it is to be part of something beautifully finished, like a book with pages too many for us to count, but a book nonetheless. If the universe is infinite, then it is a song without end. A river without a shore. A sky without horizon. To live within it is to be part of an eternal unfolding, a story that never concludes, only deepens. Both visions are wondrous. Both stretch the heart as much as the mind. And so, as you drift toward sleep, hold this thought gently: whether finite or infinite, the universe is more vast than we can ever walk, sail, or dream across. Its scale is beyond our footsteps, beyond our lifetimes, beyond our history. And yet, here you are, small, and yet aware. A fragile human being who can look up, and dare to wonder, how big is the universe? That wonder is infinite enough. Close your eyes, and let your thoughts float free, beyond the edges of what we can see. We've spoken of infinity, of whether the universe stretches without end or bends back upon itself. But what if there is something even stranger? What if our universe is not the only one? What if, far beyond the curtain of what we can observe, there are others, countless others, each with their own skies, their own stars, their own possibilities? This idea is called the multiverse. A word that feels almost like poetry: many universes, layered like whispers. To consider it is to open a door into a hall of mirrors, where each reflection might be a reality of its own. Imagine standing before an ancient library. Its shelves stretch farther than your eyes can see. Each book on the shelves tells a story, complete and unique. Our universe, everything we know, would be just one book. But surrounding it are countless other volumes, each telling another tale. Some might be wildly different. Some might echo our own, with small variations: a tree growing in another place, a life lived in another way. This is one way to picture the multiverse, a library of realities, infinite and unending. Scientists, of course, approach the idea more carefully. They ask, what does physics allow? Does the math of the cosmos leave room for other universes? Surprisingly, in some theories, the answer is yes. One possibility comes from the shape of space-time itself. If the universe is infinite, then beyond our observable horizon, there may be regions forever out of our reach. Not just because they are far, but because expansion pulls them away faster than light could ever bridge. Those regions might look much like our own, with galaxies and stars, or they might be very different. In this picture, the universe is already a kind of multiverse, an endless quilt, stitched together from patches we can never see. Another vision comes from the idea of cosmic inflation. At the dawn of time, the universe is thought to have expanded unimaginably fast, in the briefest blink of existence. But what if that expansion didn't happen everywhere at once? Some parts may have slowed, creating our universe, while other regions kept inflating, bubbling into new universes. Like soap bubbles floating together in a foam, each universe could be a bubble, separate, never touching, but existing side by side in the vastness. Our cosmos, then, would be just one bubble in an infinite froth. And there is yet another possibility, drawn from the mysteries of quantum physics. At the smallest scales, particles do not follow one single path. They shimmer with probabilities, choosing many routes at once. Some thinkers wonder, if every possibility happens, then perhaps every choice creates a new universe. One where you turned left instead of right. One where a star lived instead of dying. One where entire galaxies formed differently. If so, then reality itself might be branching endlessly, like a tree with infinite leaves, each leaf its own universe. But pause for a moment. Breathe. These are not certainties. They are dreams painted with equations, possibilities born of mathematics and imagination. The multiverse may be real, or it may be only an idea, shimmering on the edge of science and philosophy. Yet, there is comfort in the thought. Because it means our universe, as vast as it is, may not be alone. that the cosmos itself is part of something larger still. And in a way, this mirrors our own lives. We often wonder, am I alone in my thoughts, in my dreams? And the answer is no, we live among others, each with their own inner worlds. The multiverse is like that, but on a cosmic scale. Let's dream a little deeper. Imagine, for a moment, another universe where the laws of nature are not the same as ours. Perhaps in one universe, gravity is weaker, and stars never form. In another, atoms cannot hold together, and light never shines. Those universes would be quiet, dark, empty. Yet somewhere among the endless possibilities, one universe has just the right conditions for galaxies, stars, planets, and life. That universe is ours. This idea, sometimes called the cosmic lottery, makes our existence feel both fragile and miraculous. Among all the possibilities, we live in one where the balance allows us to look up at the stars and ask questions like this. To dream of infinity, to wonder about other worlds. And then, there is the most human thought of all, if parallel universes exist, are there other versions of us? Perhaps, in another universe, you are sitting in a different chair, hearing a slightly different story. Perhaps in another, you chose another path in life. Or perhaps, in another, you never existed at all. These ideas are not science so much as reflections of longing, but they remind us how precious this moment is. Because whatever may be elsewhere, here and now is unique. The multiverse, whether real or imagined, is less about proving and more about expanding our sense of wonder. It asks us to stretch our imagination past the limits of our observable world. To see ourselves not only as inhabitants of one universe, but as dreamers who can imagine countless others. As you drift deeper into rest, picture the night sky once more. Each star a spark in the darkness. Now imagine those stars multiplied, not just across our universe, but across countless universes. Each shining with its own story, its own song. A cosmic chorus, unending. And in this chorus, we are but one note, yet a note that can listen, and wonder. So let the thought linger gently, we may never know if parallel universes exist. But in asking the question, we already open a doorway. A doorway to infinite possibility. A doorway to dreams. And tonight, as you close your eyes, perhaps you step softly through that doorway, into a universe where peace and stillness stretch forever. Take a slow breath, and let it out. You are here, in this moment, listening, breathing, alive. And yet, when we look out into the universe, we see distances so immense, timescales so long, numbers so vast, that our existence can feel impossibly small. But small does not mean unimportant. Small can mean precious. Small can mean unique. Think of Earth. A pale blue dot, as Carl Sagan once described it, suspended in the endless black. If you could step far enough back past the clouds, past the planets, past the quiet rings of Saturn and the cold orbits of Neptune, you would see our world as nothing more than a fleck of light, tucked into the vast sea of stars. From far enough away, you could cover the entire planet with your fingertip. Every city, every mountain, every ocean, every laugh and tear, hidden under that small shimmer of blue. Now step back even farther, past our solar system, into the Milky Way. There. Earth is not even visible. Our sun itself, the great light that nourishes all life here, becomes just another star among hundreds of billions. A single bead of fire in a glittering spiral. And then, farther still. Beyond our galaxy, where the Milky Way itself is just one island of light among countless others. Billions upon billions of galaxies, stretching into the darkness. Each galaxy filled with its own suns, its own possible worlds. In this grand map of the universe, our Earth does not even register. It is smaller than a whisper, softer than a sigh. It can make you pause, can't it? To realize how tiny we are. A human life, brief as a flicker. Our planet, a pebble in the cosmic ocean. Compared to the scale of the universe, we seem to vanish. But here's the gentle truth: smallness does not erase meaning. In fact, it may create it. Imagine standing on a beach at night, listening to the waves. Each grain of sand beneath your feet is nearly invisible. And yet, without each grain, the shore would not be whole. Without each wave, the ocean would not sing. We are like that, small, yes, but part of a greater whole. From a scientific view, our place in the universe is astonishing. The atoms in your body, carbon, oxygen, iron, were forged in the cores of ancient stars. Billions of years ago, those stars lived, burned, and exploded, scattering their elements across space. Those atoms drifted, joined, formed new stars, new planets, and eventually, you. You are literally made of stardust. The same matter that glows in distant galaxies burns quietly inside your veins. So when you look up at the night sky, you are not just looking at something far away. You are looking into a mirror of sorts. The universe is not only around you, but within you. In every heartbeat, in every breath, you carry the story of stars. And yet, we ask, does the universe care about us? Perhaps not. The cosmos is vast, indifferent, continuing its grand dance whether or not we exist. Galaxies will form, stars will die, space will expand regardless of human witness. But maybe the deeper truth is this: we care. We give meaning. We are the eyes through which the universe sees itself, the ears through which it hears its own silence. Without us, the stars shine, but no one wonders. With us, the stars become stories. This is our place in the vastness, not to be rulers of the cosmos, but to be its storytellers. To take the infinite and fold it into words, music, questions, and dreams. There's another way to think about it. Imagine if the universe were a great, endless symphony. Each galaxy is a movement, each star a note, each planet a faint vibration of sound. Then what are we? Perhaps we are the listeners. The ones who sit quietly, eyes closed, and hear the music. Without listeners, even the most beautiful symphony is just sound. But with us, it becomes meaning, emotion, memory. So yes, we are small. But we are also witnesses. And witnessing itself is powerful. Think, too, of time. The universe is about 13.8 billion years old. Compared to that, a human life is no more than a breath, a blink. Yet what we do with that blink can ripple across generations. A thought shared, a kindness offered, a discovery made, they echo. Just as starlight travels across space, our actions travel across time. The pyramids, carved thousands of years ago, still speak to us. The words of ancient philosophers still reach our ears. The discoveries of Newton and Einstein still shape our understanding of the stars. Tiny lives, brief as sparks, and yet their light endures. In this way, even the smallest flicker can help illuminate the vastness. There is a gentle paradox here: the more we understand our insignificance in scale, the more sacred our existence feels. Because against impossible odds, in a universe so huge it defies comprehension, we are here. Breathing. Thinking. Wondering. Out of all the endless possibilities, consciousness has bloomed on this little world, orbiting an ordinary star. That alone is a miracle. So perhaps our place in the universe is not to measure up against its immensity, but to marvel at it. To let it humble us. To let it remind us of how rare and fleeting life is. And then, to cherish it all the more. Picture yourself again under the night sky. The stars above are ancient, their light traveling millions of years to reach your eyes. You will never touch them. You will never walk among them. And yet, in this moment, they are yours. They shine into your gaze, becoming part of your memory, your story. In that exchange, light traveling across the abyss, Entering your soul, you are connected to the cosmos. This is the human place in the vastness, to be the bridge between silence and song. Between the infinite and the intimate. Between the stars and the beating of your own heart. So as you drift toward sleep, let this thought cradle you: you are small, yes, but you are starlight brought to life. You are the cosmos, wondering about itself. And though the universe is vast beyond measure, there will never be another you, in all its reaches, in all its time. That uniqueness is its own kind of infinity. And now, we come to the end of our journey. The universe stretches on, larger than our minds can ever hold, older than any story we can tell. We have wandered together through its history, its distances, its mysteries. We began with ancient eyes staring at the night sky. We followed beams of starlight across impossible distances. We listened to the echoes of the Big Bang, and we drifted past galaxies, horizons, and questions without end. But here, in this moment, the journey becomes still. The stars remain above you, glowing quietly as they always have. The galaxies spin. The universe expands. Yet here you are, breathing in the soft quiet of night. The cosmos continues on its grand, endless rhythm, and you, too, are part of that rhythm. There is a certain peace in knowing that the universe does not rush. Stars live for billions of years. Galaxies drift slowly, like petals on a vast, unseen stream. Even the expansion of the cosmos is gentle on human timescales, like the soft stretching of a dream. Compared to such vastness, our worries shrink, our burdens soften. What troubles you today is but a breath against eternity. You can let it go, for a while. Perhaps this is why we look to the night sky, not only to measure, not only to wonder, but to feel perspective. To realize that while the universe is unimaginably large, it is also quiet, patient, forgiving. It gives us room to pause. Room to breathe. Room to simply be. And in that space, we find rest. So, what is the size of the universe? The truth is both simple and profound. The universe is bigger than we can ever see. Bigger than we can ever measure. Bigger, perhaps, than we can ever truly imagine. It stretches beyond the limits of light, beyond the reach of time, beyond even the grasp of our deepest questions. And yet, it also fits inside the human heart. Because when we look up, we carry it with us. In memory. In wonder. In story. The universe is as vast as eternity, and as close as the breath you are taking right now. As you lie here, listening, perhaps you feel that gentle stillness settling around you. The kind of calm that comes when you know you are part of something greater, something infinite. You are small, yes. But you are not lost. You are held. You belong to the stars, and they belong to you. Close your eyes now. Let the last traces of starlight drift softly through your mind, like silver threads of a dream. Let the vastness become quiet, like a lullaby humming from the farthest galaxies. Let yourself rest, knowing that the universe will keep on turning. The galaxies will keep on shining. And tomorrow, the sky will still be waiting for you. And with that, dear dreamer, our journey comes to a close. Thank you for walking with me, beneath the stars, through time and distance, into the heart of wonder itself. This has been the Dreamy Scientist. Until next time, may your dreams be gentle, and as endless as the universe. Good night. Crescent Moon.